A psychologist and a statistician were having a conversation together. The psychologist asked the statistician, "Have you ever heard of the famous psychologist called Pavlov and his experiments?" And the statistician thought for a moment and replied, "Pavlov? He rings a bell curve." I just saw that terrible joke this morning, so I wanted to share it with all of you. Hello everyone, welcome to my channel, and welcome to another statistics video recording. My name is Dr. Chris, and I hope you're having a wonderful day so far. Thank you very much for tuning in. In our last video, we talked about finding a confidence interval for a proportion, and then in that video, I showed you an example of how to get the z-score for the confidence interval formula that goes with the proportion formulas. And before we move on to confidence intervals for a mean problem, I thought it might be helpful to do some more examples finding that z-score given different levels of confidence. And then also in this same video, we're going to talk about the same thing for the t-score, which is needed for the mean interval formula. So I thought we would do both of those in this same video before moving on, because that might be very useful for you. So that's going to involve some more sketches of normal curves, and now, soon, t-curves as well. So on that note, let's get started, shall we? Yeah! The first thing we should start pointing out is that for confidence intervals that involve proportions, the number that you need to use is the z-score in that formula. But if it's a mean problem, then you have to use the t-score instead. So if you've been wondering why sometimes the formulas use z in the confidence interval formula and why other times they use t, that's the reason. Proportion problems use z and mean problems use t. That is the difference that you need to remember. And now on that note, I am going to give you a nice little mnemonic to help you remember which is which. Think of the word mean and the letter T. If you were to put the letter T onto the end of mean, the result is the word meant, which is a proper word. Now try putting the letter T onto the end of proportion. The result you get is proportionate, if that's how you would pronounce it, which is obviously not a word. That tells you that T does not go with proportion, it has to go with mean. That is a great way of remembering which is which. So hopefully you will find a little mnemonic device helpful. So now let's go over to the proportion formula again for a confidence interval, which you see on your screen now. As you can see, that involves the z-score. And I'm going to give you another example or two of how to actually find that z-score. So let's go to the paper, shall we? Let's talk about an example of finding a 99% confidence interval, the z-score, if it's a proportion problem. Here's what that means. You would first of all draw your normal bell curve, and when we say 99% confidence, that means that between positive z and negative z, the same number but positive and negative, it means that we're going to have 99% of the curve. Or as a decimal, that's going to be 0.99. Goes in the center. Well, if you've got that amount in the center, that means that 1 minus that is going to be left over, which is 0.01, and then half of that is 0.005. That's the amount that goes in both tails. And then also down here. So that means that the lower and the upper tails each get 0.005, the remaining areas. So now the question is, what z-score cuts the curve in such a way so that you get 0.005 above it? And then that is when we can go to the TI-84 graphing calculator. So here we go. So remember, we do second and vars for distribution. We would pick the third one, inverse normal, and then we're going to go with 0.005. And then the answer is, we can just drop the negative sign here. The z-score is going to be positive 2.5 57583. There we go. That would be the z-score to use for a 99% confidence interval if you've got a proportion problem. And it doesn't matter what the sample size is, that's the z-score that's going to be used. Here's one more example with a 90% interval. This time I've drawn another curve here. This time that means 0.90 is in the middle, and the upper and lower tails are the ones of interest. If we've already allocated 0.9 of the curve, that means that 1 minus that, which is 0.10, that amount is left over. And so if we divide that among both tails, 0.10 divided by 2, we get 0.05, excuse me. And so that means that the upper tail has 0.05 area, and so does the lower. And then same question here, what z-score splits the curve in such a way so that you get 5%, 0.05 above it? Going back to the graphing calculator again, we have, let's do the same thing here. Okay, so inverse norm, this time we're going to say 0.05. And again, we're going to drop the negative sign. So we're going to say that z equals positive 1.64485, just rounding to 5 decimals. And that's how you get the z-scores for the different confidence levels. And then in the case of a mean problem, that's when we use the t-score. Now, the t-distribution is very similar in appearance and use to the normal distribution. If you were to examine one in a textbook, you will find that a t-distribution is a bit more peaked than a normal. So a normal curve for proportion would look a little bit like this, a bell curve. A t-distribution would look very similar. It would be a bit more peaked in the middle. So it's still symmetric, but it tends to come up a little bit higher than you would expect for a normal. And the other difference between the two is a normal distribution looks the same in terms of height, at least on paper anyway, whereas a t-distribution actually changes shape slightly depending on the sample size that is used. It takes as an input something called degrees of freedom, or DF is the way it's abbreviated, degrees of freedom. Now for a confidence interval formula, DF is going to be equal to the sample size minus 1, so n minus 1. That is the required input for a t-distribution. So with a normal, your inputs would be the mean and standard deviation, which for finding a z-score would be 0 and 1, whereas for the t-distribution, we don't put in the mean and standard deviation, we put in the degrees of freedom, which would be sample size minus 1. So let's now look at some examples of how that works using the TI-84 graphing calculator. I'm now going to show you an example of how this same process works, but this time with a mean scenario, which is going to require the t-score, the t-distribution. Let's assume it's a 95% interval, and we've got a sample of size 12 subjects. I'm giving you the sample size because, again, remember, the t-distribution takes as input df, which stands for degrees of freedom, and that's going to be the sample size minus 1. Here, that's going to be equal to 11. We'll get to that in a moment. So now, we are going to draw the t-curve, which pretty much looks the same, very similar to a normal curve, but as I was saying earlier, it tends to be a bit more peaked, meaning the middle comes up a little bit higher, but it's still symmetric. And the area under the curve total is still 100%, or 1, so we can still use our same techniques. So with 95%, remember we've got 0.95 in the middle. Sorry about that. 0.95. So we still have that amount to look forward to in the middle. So nothing new there. And then the upper and lower tails are going to have half of what is left over each. So doing the math here, we've got 0.05 left over, and half of that is 0.025. That's the amount that goes in both the tails. And this time we draw a negative and positive t, because it's the t-distribution, and now we need to go to our graphing calculator to find out what value that is. Okay, here's how we do that. So going to the calculator, we go to second vars again, and this time we want to go to the fourth option, which is inverse t. And the inputs to use here are the probability of interest, which is 0.025, we just derived that, comma, and then the degrees of freedom, which here is going to be equal to 11. Remember, that's sample size minus 1. And so the calculator is telling us that this number on the screen is the t-score. Again, we'll just make it positive. So 2.2009, we'll round up 9. And that would be the value that we'd use in the mean confidence interval formula, and we'll talk about that in another video. But for now, again, this is just how you get the t-score. Here's one more example. This time, let's find the t-score to use for a 92% confidence interval, assuming the sample has size 20. So first things first, we need to know that degrees of freedom is going to be equal to 19 in this case, which is 20 minus 1, sample size minus 1 again. And if it's 92% in the middle, that means the middle has 0.92. And so that means that 0.08 is left over of the curve. And then splitting that into both tails, we get 0.004. I'm sorry, 0.04. And so that means the upper and the lower sides have 0.04 each. And now we just need to know what the t-score to use for that is. So let's go back to our calculator again. And number of second vars, the fourth option, inverse t, we just discovered that the value to enter for the upper tail is 0.04, comma, and then our degrees of freedom, which is sample size minus 1, 19 in this case. And there we have it. The t-score to use, again dropping the negative, is 1.84953. There we go. So again, in the formula, which I haven't yet shown you, for the confidence interval mean, you're going to use the t-score of that number we just found. And again, if our sample size for this problem happened to have been a different number, something other than 20, that t-score would have been a different number, so these are not worth memorizing. And there you have it, ladies and gentlemen. Those are some more examples of finding the z-scores and t-scores for different situations for a proportion problem and also the upcoming mean problems. So please wait for my next video about confidence intervals with means, now that you've got a handle on using the t-scores and how to derive them. Thank you very much for watching this video today. I hope it was helpful for you. If you have any topics on mathematics or statistics you'd like me to talk about, please let me know. I will be doing some more videos about confidence intervals and later hypothesis testing for you. I hope you enjoyed this video as much as I enjoyed making it, and have a lovely day. Cheers!